Hello, everyone. Welcome to the BDLA webinar, Driving Sustainability with Autodesk, Tools for Low Carbon Design with Cesar Escalante. If you have a question, please put it into the Q&A section, and we will get to it after the presentation. Now, our founder, Peter Rumsey, will take over with a brief introduction of the BDLA and to introduce Cesar.
Welcome, everybody. We're really excited about today's webinar. Just as a reminder, this is part of Stanford's Building Decarbonization Learning Accelerator. And the BDLA project is one where we make teaching resources available for professors and educators for free. And we have a website, bdla.stanford.edu, that we would invite you to go to and check out. We have videos of past webinars, but more importantly, we have teaching resources for those of you who are teaching architecture, engineering, construction management, sustainability, and other courses that want to integrate building decarbonization concepts into your courses. There's things like slide decks, case studies, reading material, and the like that you can use, slot into existing courses, and adapt to your teaching style or content. And there's even enough content there to create a whole new course, so which some people have done. We have users all over the US as well as globally, including top universities all the way down to community colleges. So there's a wide variety of material and uses, and we do also have a fair number of private sector people that take advantage of the teaching tools that we've made available. So I'm really excited today about Autodesk. I went to the Autodesk University International Conference, their annual conference last week, and it was very widely attended and very exciting group of people. Autodesk does a whole lot of things, but I did want to tell you about a recent visit that I was able to make to Autodesk in San Francisco, where they're headquartered. And in their gallery, where it's where they show off different things that Autodesk tools do, they had a lander, a lunar lander that was designed to land on the moons of Mars and Saturn. It's kind of very esoteric thing designed by Jet Propulsion Laboratory as in conjunction with Autodesk, leveraging Autodesk's latest and greatest tools. One of the things that they did is they designed the structural system for this lander using one of their tools called Fusion 360. And it's together with some of the AI enhancements that are now available with that. And they were able to iterate on the structural system for this lander and came up with a system. The structure looked more like a tree with branches that came in different directions. The reason why that was the strongest light structure for that particular lander, and it resulted in a 30% reduction in weight, which I find that revolutionary. I think what we're going to see in the future is tools being able to show us ways of designing buildings that don't look like the buildings that we're seeing today. And it will be everything from structural systems being lower material, therefore lower embodied carbon, to how we operate buildings in a more optimized way. And I think that Autodesk is on the forefront of figuring these things out. So we wanted to bring them to you and have a discussion about where are the tools now, what are some of the things they can do that relate to decarbonization. And I think hopefully in the discussion we can spur you all to ask questions about where are we today, but where could we be in the future. So we welcome that discussion. I'd like to introduce our speaker today, Cesar Escalante. He's an architect with expertise in all facets of BIM, administration, mobile and cloud technology, and project management systems. He works as the technical marketing manager at Autodesk, where he serves as a global spokesperson for building product innovation. In addition, he teaches BIM at Stanford, and I know some of his students and even his TA, and chairs the National AI Technology in Architectural practice, TAP knowledge. Cesar has driven large-scale BIM strategies and held roles at top firms, including Gensler and HOK. We were just talking earlier that we were probably working at HOK at the same time about 10 years ago. His project portfolio features the $12 billion Santa Clara City Center, Salt Lake City International Airport, and major Apple and Salesforce campuses. He's a frequent speaker on technology's impact on design. He's joined today by his colleagues Karina Marinescu and Giuseppe Ardito. And Giuseppe works on the next generation of Insight, one of the Autodesk tools, particularly focusing on operational carbon, energy, and decarbonization workflows. So that's great. Giuseppe will be available to chime in during the Q&A period. And Karina is a senior project owner at Autodesk, where she helps lead the development of Autodesk sustainability tools with a particular focus on total carbon and sustainability workflows. So we have the A team from Autodesk here, and I'm looking forward to a very stimulating conversation. So with that, I'll hand it over to Cesar, and thank you for joining us today.
Thank you, Peter, for the introduction. I'm excited to be here and sharing some of the latest updates in tools and in market offerings for low carbon analysis in building design. Before we get started, just a quick safe harbor statement. You might see in this presentation forward-looking capabilities of our products, and we just want to make sure that you don't make purchases decision based on those anticipated features. Again, my name is Cesar Escalante. I am Technical Marketing Manager focused on architectural solutions. And today I'm here to talk about a survey of solutions that support carbon analysis and building design. And first, we're going to look at a quick introduction on where we're at and why it's important to address carbon analysis. And then we're going to look at one of our latest offerings, Autodesk Forma, which is a cloud-based solution that helps us analyze and track carbon emissions. We're also going to look at the latest capability of Insight that help us calculate total carbon emissions, including analytics and ability to simulate reduction strategies. A lot of what you will see are capabilities announced at Autodesk University, so this is probably the first time it's shown after the conference. I'm also going to talk a little bit about how our tools support construction activities using Autodesk Construction Cloud, take off carbon accounting, and then we'll give you a glimpse on the future development and then answer some questions. So let's take a look at a quick introduction of our tools. I mean, there are global trends that are driving the need to support and deliver tools that address global emissions. Everybody knows this statistic: 42% of the global emissions come from the built environment. And maybe Autodesk want to help you do something about that in your work. There's also a huge demand of increased regulations. There's more disclosure, more reporting requirements as a result of new legislation in different US states and Europe and across the globe. Decarbonization is a target outcome in a lot of your projects, and net zero commitments are requiring us to reduce climate emissions and are driving new business models and companies to rethink new investment priorities and development plans. And there's our global efforts to align data with standards for sustainability across the whole value chain. A global Building Data Initiative, which started at the European Union, the Embodied Carbon Harmonization and Optimization Project, which started in the US, the Chalio Declaration, which was signed by 70 countries that represent 35% of global emissions. And all these trends are supporting the need of doing something about carbon emissions from the software perspective. And this is nothing new. We've been committed in delivering sustainable solutions, which started back in 2022 when we introduced Total Carbon, which is a variety. We offer a variety of different carbon analysis tools, addressing different points in the design process. We responded to customer needs, requiring for more integrated tools that use a common set of building information data. And we've been working ever since in improving the experience of more frictionless data sources, better data analytics, better insights. In 2023, we introduced the paradigm connecting workflows with software. We addressed key problems like how we can address simple, open, extensible tools. And last year, the next generation of Insight was released with the release of Revit. It comes now integrated with Revit. We gave headline announcements of what this new tool look like, showcasing increased scope and features for benchmarking. We also launched last year the ability to connect Insight with AIA 2030 reporting tools and how it's built in a more modern cloud infrastructure. And it's been a journey for us, several years in the making. And as we explore our solution landscape, there are better point solutions supporting different stages of design. It's a multi-year journey that spans several years until we get to the place where we integrate all the solutions with connecting data. But at the moment, our solutions in market are basically around 4 offerings. We have Autodesk Forma for early stage planning, Revit Insight, which enable total carbon analysis on detailed design. We have an integration with Autodesk Construction Cloud Takeoff, which has in-app capabilities to embed environmental declarations powered by EC3 and forthcoming data at the operation site using Tandem. It's our digital twin solution for building operations, which enable us to report insights about energy systems and custom analysis in the operation side. So I'm going to focus on 3 of these solutions: Autodesk Forma, Revit Insight for Revit, updates, and Takeoff. Let's start with the very first one. Autodesk Forma, it's our latest offering in market that support early stages of design. I'm not going to talk about what all the capabilities of Forma, but how Forma supports carbon analysis. Traditionally, detailed carbon analysis has been mostly evident and possible in late stages of the design process. And this delay impact our ability to optimize low carbon outcomes. So a few years ago, we partnered with Zscale to address this challenge in early stage design and fill the data gaps using machine learning and enabling carbon smart decisions from the moment you design massing solutions. A very quick overview of what Forma is. This is our cloud-based platform that enables you to quickly create, analyze, and optimize buildings at the early stage of planning and site design. It's integrated with real-world data, AI-driven insights, and it's infused with collaboration tools that enable multiple people to provide feedback in a collaborative manner. Forma streamlines decision-making by supporting more sustainable projects. Forma provided with a fast setup process to geolocate your project and ordering contextual data from open source places. It also has you can create proposals that can be analyzed with a wide variety of environmental analysis. It allows you to connect your workflows with other ecosystem authoring tools like Revit, Rhino, and Dynamo. It provides open APIs that allow third parties to develop an extended ecosystem to target specific operations. Now, I'm just going to focus on the features that make Forma an analysis tool for carbon analysis. So the most impactful carbon-related decisions are made when the least project data is available. So traditionally, detailed carbon analysis is only possible late in the design process after key design choices are locked in. So Autodesk, in partnership with Zscale, created a joint analysis tool associated with Forma that apply machine learning to fill the data gaps in early stage design, allowing you to make carbon smart decisions from day one. And the idea is that design teams can focus on making those changes early in the design process while they have the ability to be in control of the major structural design systems and interior systems when project details are still emerging. Now, the process involves multiple steps. First, we begin by converting basic massing geometry, like floor area, building height, number of stories, structural systems, into a structured set of predictors. These predictors are chosen because they have been shown to correlate strongly with material quantities based on an analysis over 5,000 bill of materials, from which we learn how to accurately predict. Then we estimate structural material quantities. Using this machine learning model, the system predicts total structural material required per unit area in a given design. Then we estimate total materials in a more refined way, divided into major categories like concrete, steel, wood, and we further refine different subtypes, like hot rolled steel or different concrete strength. These steps produce a preliminary bill of materials at a schematic level. And then we apply carbon intensity data overlay on these materials. The values are sampled from leading global databases reflecting the range of carbon footprints associated with different supply chains. And then the final step is to present a range of carbon outcomes for each design proposal or design scenario. The carbon intensity data, it's at the core of these early stage insights. Then, we create a distribution of possible materials that meet the product specification on a sample curve measure at 20% percentile, 50% percentile, and 80% percentile. This is where Forma fill the gap on potential scenario-driven outputs and gives you a picture of what is the carbon range that display what is the impact of carbon emissions. The default set for these percentages is 50, representing the best practice. So here's how it actually works in the product. This is a contextual mass representation of a building divided by different stories. We assign a building type, a structure, assumption, and an envelope material, as well as a window to wall ratio. You can swap building types and structural and envelope assumptions to create different scenarios and compare it side by side. The analysis takes about 5 minutes to run, and it gives you estimate global embodied total carbon associated with the choices assigned. You can vary different options for structural envelope. And then in the carbon definition, you can pick what percentile of distribution of carbon estimation you want to focus on for the different systems, envelope, structure, MEP systems. And as such, you can start creating different scenarios with potential mitigation activities. The best part comes when you can compare these different scenarios. So here you see the history of the different building choices, structural systems, and MEP systems associated with the mass solution. And using the compare tool, you have the ability to compare different scenarios and the global impacts and total embodied carbon estimations broken down by different systems. I think at this stage, the goal is to provide a directional definition on what would be the most appropriate strategy or combination of strategies that lower the embodied carbon impact. So that's been the carbon offering on the conceptual stage at the moment. At Autodesk University, we also announced the beta of an integration of Forma with Autodesk Insight. I'm going to show a little bit of that at the end of the presentation in the roadmap and ways in which you can get engaged. Now, the second solution I want to explain about is new updates on total carbon calculations using the next generation of Insight for Revit. Let's jump right into it. Over the past couple of years, Insight has significantly evolved, in particular in the calculation of energy analysis. Since their relaunch in 2016, we have listened to customer feedback about providing a tool that is more customizable, that is more transparent, and then display analysis and more visual results. This led to the introduction of system analysis. It's a feature that's embedded with Revit that use Energy Plus and OpenStudio. And then to address the industry growing focus on embodied carbon analysis, we developed Carbon Insights and launched a tech preview in 2023. And last year, we introduced the next generation of Insight, incorporating both carbon and energy analysis at its core. This new version using the same type of analysis as the system analysis for energy analysis and ensure more interoperability. All right, let's take a look what the workflow looks like. You start by creating an energy analytical model directly in Revit and send it to Insight. This gives you a connected workflow where your building model becomes the basis for energy and carbon analysis. Then in Insight, which is a cloud service, you can explore the results of a total carbon dashboard, which breaks down the body and operational carbon. You see energy consumption, life cycle carbon contributions, visualized in clear data-driven formats. And then from here, you can create custom dashboards tailored to specific needs in your project. You can define custom metrics, set custom targets, create and adjust factors, add new ones like fuel sources, system assumptions, and reflect on a specific project needs. These allow you to move seamlessly from design to performance evaluation, detailed design, allowing you to connect the Revit model with Insight Advanced Analytics. Let's take a look at some of these dashboards. So once in Revit, once an energy model is sent for processing, Insight provide you with a dashboard of the energy and carbon outputs. Now, just a quick reminder, Insight is available to anyone who has a Revit subscription or who is a subscriber of the AC collection. And starting last year, it comes pre-installed with your Revit installation. It used to be a standalone package, no more anymore. Once the energy model is uploaded to Insight, you are presented with an overview of dashboards where you can see key sustainability metrics and inspect factors like building lifespan, annual energy use intensity, operational and embodied carbon. And you also have the option to configure embodied carbon analysis on a dedicated EC details page. Here, you can inspect the model, the different breakdown of model contributions on carbon emissions, and you can also customize different carbon emission definitions to the different materials in the model. Notice that on the panel on the right side, there's a curated list of EC definitions. This includes global generic data from EC3, as well as custom entries. Then you'll be able to expand this even further, adding custom definitions from data providers or switching to other third-party alternates like Ocobadat or Building Transparency C3 to better suit your project needs. You can also create location-based filtering and making it easier to align your selections with regional standards and regional benchmarks. All right. Another thing we did last year is the integration of Insight with the AIA DDX 2030 reporting tool. You can now streamline how you report to the AIA 2030 commitment by sending project data directly from the BIM model into the AIA Design Data Exchange. This was one of the headlines last year at the AIA National Convention. So instead of exporting, reformatting data and manual data, you can generate a DDX ready report in just a few clicks. Here is a quick video of how that works. You start by accessing the AIA reporting tool by clicking the three-dot menu on the project thumbnail. You enter your credentials and start filling the form with mandatory data. You inspect available benchmarks to compare the results powered by Zero tool and through the AIA DDX. Next, you add optional information about renewable energy, consider for the analysis. In this example, we're considering photovoltaic panels information. You can add custom factors and metrics to explore and expand these factors. And then you connect to the DDX tool. Here you can configure embodied carbon definitions directly into your model and change it and adapt it to the project specifications. You can inspect results using different charts, make different adjustments as needed during design development. And then you can inspect the results in the AIA DDX reporting page and continue filling the form with details about the project, about the embodied carbon requirements, and submit it directly to the AIA. By doing this, you can lower the risk of errors because there is a direct connection between the BIM model, the reporting tool, and your projects. It accelerates your project's ability to be counted against the AIA 2030 reporting tool. All right, that is some of the updates we've done with Insight, integration with Revit, how it supports carbon analysis at a detailed design level. Let's take a look at the next solution, which is ACC Takeoff integrated with embodied carbon estimates. This is directly integrated in your quantity takeoff workflows supported in construction and pre-construction activities. It allows you to connect your workflow with EC3 databases. It allows you to map material classification codes like master format and unit format against custom carbon factors, allowing you to generate carbon information, carbon reporting, alongside with quantities and cost. Let's take a quick look on how this works. ACC, or the Autodesk Construction Cloud, has now the ability to embed embodied carbon metadata directly into elements managed by Autodesk Takeoff. This happens during pre-construction and construction workflows. As you define your takeoff types, whether that is concrete, steel, or wood, you can assign an embodied carbon factor alongside the cost data. This gives you visibility into the environmental impact of your design choices at a precise moment when decisions are finalized during the construction process. You can also compare snapshot versions of your project to understand how changes in material quantities and classifications impact both the cost and carbon at the same time. Once you capture the data, you can export it for reporting, whether that's for internal sustainability goals, downstream applications, client requirements, or just compliance documentation. This capability is right now in public beta, but it's available to any users of ACC and Takeoff right now. Let's take a look at a video on how this is actually, this work on the product. So the embodied carbon metadata is now integrated into the quantity takeoff process. This is done through a live connections of the element with an EC3 database. So when you classify materials, ACC Takeoff use the classification code to map it against an EC3 carbon data. At the moment, we support master format codes, a selected set of uniformat codes that align to very specific materials. Takeoff automatically produce both quantitative and carbon estimates without requiring a separate workflow. And this is just the start. We're continuing to expand this mapping beyond classification codes and working towards including material names and other metadata to increase coverage and improve material types. At the bottom line, this means that as you complete your takeoff, you're not only getting costs and quantities, but you're also getting estimates of embodied carbon, all under the same workflow. The calculation can be exported to spreadsheets and connected to other tools as needed. All right, I'm looking at the clock. I'm 20 minutes from finishing. Let's take a look at where Forma and Revit Insight is focused in the near future. Let's take a quick peek of what might be coming soon or very soon. You've seen so far a survey of different point solutions that support different processes in the design cycle. But as you might have noticed, although these are useful, they are right now are fairly disconnected as far as data. Our goal and our vision is to support integrated, an integrated one second, I need to come back to my slide here. Yep. Our goal is to support an integrated ecosystem where data can be shared from early stage design all the way to operations. And in our process to get there, we're making fundamental upgrades in some of these tools. The first one is that this was announced at Autodesk University. It's the integration of Autodesk Forma with Insight, which allow us to define expanded building types, expanded construction and material choices, and provide you access to total carbon analysis using the same Insight engine that powers the Revit tool. Our goal is to create a unified story of data, carbon data. We understand that this tool needs to form connected workflows that allow you to work iteratively and collaboratively in any design phase without losing the data. So this vision of shared data it's our vision of shared carbon services. And this is the biggest piece of this puzzle is already here. And it's a collection of APIs that give us a granular access to design data across these different products. With this granular and shared access to design data across the different stage phases, we can turn into a more comprehensive look at sustainability data and how this carbon data flows from early stage design to design development to construction processes all the way to operations. And as announced at Autodesk University last week, we are opening up a sustainability data API available now. The sustainability data API, which is now available in Autodesk Platform Services, is designed to address some of these data challenges we're working with sustainability workflows. It provides a standardized interface that enables the integration of multiple sustainability data sets across Autodesk products. And it's a framework designed to connect you with the right sustainability data sets, allowing not only to connect our internal flow data within the Autodesk ecosystem, but extended it to third parties and open the ecosystem to third-party developers. Or data providers. Just for clarification, a data provider describes companies that curate sustainability data sets and that support and connect with the Autodesk Data API. At the moment, the API supports carbon data for material categories provided by EC3 and Baudet. We're working closely with 2050 Materials, which are a European-based data provider for large data sets. And this connector will be soon available in the API as well. This is a quick roadmap of where we're going with this approach. While the API currently supports limited carbon data, we are working to grow it beyond just carbon data. We have the API now, it's on public beta, and we're gathering feedback. And if you want to get involved, I'm going to show a QR code and how you can get in touch with us and give us feedback on how you would like to see this evolve over time. Some of the most highly requested addition is a specific EPDS and advanced filtering. We're also supporting file-based data sets, which allow us to onboard more public data sets. This will allow you to connect proprietary carbon data with other tools like Takeoff and Insight. And from there, the API will expand to support additional sustainability data types like layer construction, building space types, climatic data, etc. So we will continue supporting new product integrations and onboarding new product data. We believe that the future is one of connected data across the life cycle. All right, I'm getting close to the end, and I'm going to open up to a Q&A. Here are some resources for your reference. This week, we launched a new certification called Design Performance and Sustainability with Forma, Revit, and Insight. It's a 5-hour on-demand learning course, free for students and educators. It was created by Dan Stein, the design technology director of Lake Flato. And he has this approach and teaching tools using real-world examples. So you'll have an opportunity to experiment with the real data on how to enable carbon analysis using these 3 tools. In addition, we have a self-paced learning course available online for free. It's called the BIM Foundation for Education courses. It's 5 self-paced courses that cover basic introductory workflows for learning BIM. This is a prerequisite in order to activate tools like Revit and Takeoff. So if you're in academia and you would like to get your students provide your students with some curriculum on how to learn BIM, this is a great resource. And then these are QR codes with links on how to get involved. If you want to sign up for the forthcoming Forma integration with Insight, please check the QR code there. If you're going to get involved with our development team, work with USEP on how to improve and better off both Insight and Sustainability Data API. There's a QR code on the screen. And if you are in the business of providing data, consider the opportunity to connecting your data with our tools. We have a dedicated page for third-party providers. Finally, we have a strong research community. You can provide your feedback on new concepts, features, challenges in your research and workflows. You may receive incentives as a token for your contributions in the form of access to our tools or free tokens for analysis. Get involved, get in touch with us. We like to hear how we can better off our tools. And with that said, I think I reach out to the end of our presentation. Here are some ways you can connect with me on social media. And if there are questions on the Q&A, I'm happy to open it up right now.
Yes, we do have one. In my experience, often projects are delivered in which MEP is design fluid. How do we move the industry to adopt the advanced Forma Insight connected workflows?
Design build are delivered in which MEP is design build. How do we move the industry to adopt Forma Insight connected workflows?
Yeah, I think, well, since Forma address early conceptual design, I think it bring the designer the ability to make big assumptions on the directional solution on MEP systems. And I think this is the perfect opportunity to bring into the table discussions on appropriate MEP systems that align with sustainability goals early in the design process. In design build delivery methods, there are opportunities to bring to the table early on in the design process both the designers and MEP fabricators and providers to rightfully discuss what is the most appropriate directional solution for a challenge site or a challenge project. So this involves basically enabling a delivery method that support these early engagements and this type of tools, it's a very easy entry point for designers to recapture their voice and be part of these discussions. And I think we are not there yet. The integration of Forma Insight is still under beta, It will be released very soon. I don't want to mention dates, but it's probably before the end of the year. I showed here on the screen ways in which you can get an early engagement of our tools, Forma and Insight. So please sign up. You'll be very pleased with the connection we're doing between conceptual design and detailed design, Forma and Revit. I think that connection is at the core of what we believe is the right direction to do embodied carbon calculations. And these tools are available to both designers and contractors. Yeah.
Let me maybe drill down into this a little bit more. I think that this question does bring up a fundamental problem we've got in the operational carbon calculation. So when we're talking about embodied carbon calculation, a lot of the embodied carbon is in the, very evident in the early part of design. We're going to have a 20-story building. It's a concrete structure. It's got this much glass. I mean, those things drive the embodied carbon. So to get a sense of the direction early in the design, it's pretty straightforward. The problem is on the energy use or the operational carbon, how do we get a sense of where we are? Architects need and want rapid feedback. And like you were showing with the Forma, changing the window to wall ratio, for example, or the overhangs or the type of glass. Architects need rapid feedback in the number of days, not weeks or months. But we have this problem that when we do energy modeling using the typical tools like Open Studio, Energy Plus, and different variants of that, the engineering team normally does that modeling, and it's complex and time consuming. And it's in that complex modeling that we put in the MEP system. And oftentimes the lighting, the electric lighting, and the HVAC system have a big impact on the overall energy consumption. And that's where unless everything's going to be standard and default, which, on sustainable buildings, normally that, we're tweaking lighting and HVAC systems to get the efficiency. So the architect is normally not sort of have their head into being able to model the MEP systems. But if the MEP team does the model, it does take weeks because the normal, workflow is put it into, these more complex modeling tools. And then the engineer will say, we'll get back to you in 3 or 4 weeks or a month. And the architect says, well, we're going to make all these decisions faster than that, right? So there's this breakdown, as I see it, that there's the simple model that's just the building envelope, but then there's the whole building model, which is like very time consuming. The engineer is very involved with that and usually leading it up. And the architects I'm working with are saying, we need answers more quickly, but we want the right answers. Cesar, that they want to know really how many lead points am I going to get because we're trying to get this, for example. So I'm just wondering, is there a point that there can be a rapid model that includes the MEP systems and that the engineer can be involved and work with the architect to rapidly get some preliminary answers, and then later you have the more detailed model? That sounds like to me it's a little bit more of the insight thing. So what do you think, or what are your thoughts on that?
Cesar, can I take the question? Because
Yeah, go for it.
So
Yeah.
basically, Peter, yeah, that's like the problem that even in the industry, you really lay down the problem there. So the fact that sometimes there are like quick architects, sometimes they need a quick answer even for some specific question associated to structure MEP. So I would say that now today is not possible that quick answer between Forma if you are basically only sketching conceptually in Forma, okay?
Mhm.
And that's the reason, like Cesar was mentioning, we are doing a connection with Insight so that these conceptual masses, they can be automatically like on the energy side, basically analyze the same as C-scale is doing, right? For the embodied carbon, quickly analyze on Insight. But I would say, I want to add another thing that if you start your workflow, not in Forma today, I'm saying just today, but in Revit with conceptual masses, you can get those answers through Insight right away. So there is an existing workflow there. And I don't know if, can I share my screen just like to see like the capabilities of,
Briefly, sure. Yeah.
yeah, let me,
Sure, sure.
Cesar, you'll need to unshare, I believe. Yeah.
There you go.
thank you so much. So this is a capability that Peter, I really would like to show you. Can you see my screen now?
Yes.
Yes.
So that's inside, okay? And this is, I mean, a Revit model. So this is an energy analytical model that has been, I mean, imported in Insight directly through the ribbon, okay?
Yes.
So what, I mean, like you were mentioning, architects should have, I mean, like, should get, I mean, some quick answer is already possible in Insight because leveraging, I mean, the factors, architects, they can create, I mean, the HVAC factors, and we provide out of the box like systems. And once, I mean, those factors are combined with other factors like windows to wall ratio, lighting power density, changing the loads, architects they can basically simulate those combinations or even just focus on combination associated to the HVAC and see in real time. So creating, I mean, dashboard, real time here, I'm changing like what are like the changes
Right.
on the energy metrics. Those are like basically all associated to, you know, swapping MEP systems. So that's like, so we are working on moving like from Forma to Insight directly and like skipping, I mean, the Revit side, the Revit part. But
Yeah.
today there are already in place some workflow where like you can get, I mean, quick answer if you connect from Revit to Insight right away.
Right.
These simulation factors are fairly new, and it serve that purpose. Create a post-analysis scenarios based on custom HVAC and mechanical factors, and see immediately the impact of that those decisions make in global emissions. And the other thing, you can also build your own. We provide some out of the box, but you can also create your own factors if you want to focus on a specific type of technology.
Yeah. All right. Well, with that, we're going to need to wrap up. And we look forward to this integrated platform that's cloud-based that the architects and engineers can be working on the same model simultaneously. That will be, quite revolutionary and amazing. You guys are right on the doorstep of having all that working together. So we're super excited about the progress you've made. And I would encourage folks to look at these tools to try to simplify and streamline the process of decarbonizing buildings and also teaching students about these coming changes in the existing tools as well. So thank you very much, Cesar, Giuseppe. Thank you guys very much for making yourselves available for this really fascinating webinar. And again, we encourage everybody to go to our BDLA website, bdla.stanford.edu, to see the recording of this webinar as well as our past webinars where we have some really exciting and national leaders in the field of decarbonization. So thank you guys. Thank you everybody for attending. And our next webinar will be with a Stanford professor named Michael Wera, who's very involved with decarbonization policy as it relates to building, zoning, and how we design our cities. So it should be very interesting as well. So thank you everybody for joining. Thank you, Lindsay, for organizing this, and we look forward to seeing you at the next webinar.